any plane curve or a plane figure, then it generates some area or some volume. Okay, so if this is the plane curve.
Sir.
Yes.
Hello, sir.
Yes.
স্যার এটা দিন প্রতিদিন আমার সাথে হচ্ছে যে কেউ আসছে আমাকে বার করে দিচ্ছে, প্রত্যেক দিন হয় স্যার, প্রত্যেকটা দিন। এবার আমি জানি না কে করছে না করছে, বাট প্রত্যেক দিন শুধুমাত্র আমার সাথে নয়, অনেকের সাথে হচ্ছে এটা। আমি বলছি আমাকে হয়তো এক্ষুনি বার করে দেবে আবার।
Is it in this class only?
হ্যাঁ স্যার।
तो हाँ सर, मुझे भी अभी अभी निकाला सर।
ওকে,
মাঝে মাঝে অন্য কাজ তো হয় কিন্তু বার করে দেয় না, মানে কথা বলছি মিউট করে দিল, অনেকবার মিউট করে দেয়, এরকমও হয়েছে।
So far I know if somebody make you muted, then there is no way to find it out that who has made you muted. Okay.
সেটা জানি স্যার, কিন্তু আপনি যদি সবাইকে অ্যাটেন্ডই করে দেন আর আপনি যদি অর্গানাইজার থাকেন, তাহলে কারোর ক্ষমতা নেই আমাদেরকে বার করার কিংবা কোনো কিছু করার।
You all are attendees only, but somehow I don't know, today it is showing 115 or 108 presenters. How it happened I do not know, and showing 30. There is no change in the setup I personally made.
The few presenters attendees one.
This is the last time I request everybody, whoever is playing this thing knowingly or unknowingly, please do not do this thing. Just try to find out how it is happening, and it's not fair. It's not proper justice to your status. You belong to some good class. Your parents are also quite respectable person, and please just don't make your parents rather make themselves ashamed of you. Please don't do it. So maybe बचपना अभी तक गए नहीं, कभी कभी हो जाते हैं, but it should not be repeated. That much I can request, because I am not a policeman. Okay, I am a teacher, I am taking the class, and your duty to perform. That's all. And whatever good lessons you got from your parents, please remember that. कोई भी पेरेंट्स आपको तो बदमाश नहीं बनाएगा ना. So definitely you are doing something, मजे में कर रहे हो, लेकिन ड्यूरिंग क्लास हो गया, बहुत हो गया बेटा, आगे बहुत चलना है. And if you inculcate this habit, if you allow this habit to continue, I don't know where it will lead you to. It's very difficult thing to control that behavior. Life is quite long and you need to see so many things. Okay, you have to be responsible. And naturally, if someday you find some of your parents are ill and he or she cannot afford your this NIT sponsorship, you have to stop your study. So please remember that day also. और जैसा करोगे ऐसा ही वापस आएगा आपके पास. That I believe. Particularly not at my younger age, I couldn't. अभी हो सकता है मैं भी आप लोग जैसा था. सब लोग बचपन में ऐसा ही होते हैं, 17-18 साल की उम्र में. But please take some responsibility, please. Okay, so we are talking about rotating a plane curve about some line. Suppose this is the x-axis. So this small length dl, if we rotate, and the portion of this curve, it is so small that we can assume it to be a straight line, and that straight line is generate some surface. Similarly, if we rotate a plane figure of area A about this axis, it will also generate some solid. So that type of thing, we need to consider the very small elements length dl or delta li, either this integral form or that very minute small finite element form. Here we consider a very small area dA, and in that way the volume generated, definitely it will be that small area multiplied by the distance traveled by this length. So these are some formal presentation about this curve. It's a general curve subdivided in many number of small elements, where these small elements can be considered to be straight lines. And if individual lengths delta Li are at any distance yi variable, then what about the area formed by this? For if it is rotating through an angle alpha in radian, then the plane curve AB of length L rotated about x-axis through angle alpha expressed in radian, it is giving us the total area generated, that is the summation of this small area generated, the small length multiplied by length traveled by the small element alpha yi. And when we consider the whole thing, then this algebraic summation extended for all the elements I1, 2, 3, 4 up to many number of such elements. And alpha is constant for throughout this length, that same angle we are providing for its rotation. So alpha multiplied by summation yi delta Li, and it is that common expression, it is known to us. So delta Li yi, that is total length L multiplied by yc. Now it is expressed in this segregated form, L multiplied by alpha yc. Alpha is a constant, yc that is also a fixed distance. So alpha yc, it is the distance traveled by the centroid while rotating about this x-axis through an angle alpha in radians, and L is the length of this curve. So this is the area generated L alpha yc, or if it is in the integral form, there also you will find integral ydA, the ydl. So that integral ydl will be L multiplied by yc, and that multiplied by alpha is alpha yc, that is the distance traveled by the centroid. Similarly, for area also, this is a plane figure rotated about this x-axis. So this distance yi and xi for this whole area, when it is rotated about this axis, then that same thing happens for this small elemental area also, and this total area multiplied by the distance traveled by the centroid of the plane figure while rotated about x-axis, this is the volume generated, and it is expressed in this form, in the statement form. Please remember this, nothing difficult to remember, just that logic. Name of these theorems are normally you will find in book either the theorems of Pappus or theorems of Pappus and Gouldinus. Theorem 1, the area of the surface generated by rotating any plane curve about a non-intersecting axis in its plane is equal to the product of the length L of the curve and the distance traveled by its centroid. And theorem 2, the volume of the solid generated by rotating any plane figure about a non-intersecting axis in its plane is equal to the product of the area A of the figure and the distance traveled by its centroid. It's very simple, but application is quite interesting and very useful also. Now this is a very small example. Here we have a rectangle of size 12 millimeter by 8 millimeter. Now for one complete revolution about this axis Z, what will be the area of the surface generated by the boundary of this element, or the volume generated by this small rectangular area 12 millimeter by 8 millimeter. Now for surface area, the top surface this one, it is indicated by the length 12 millimeter multiplied by the length traveled by this centroid of this line element for one complete revolution about this z-axis. Okay, so what about this area, top surface area? It is length 12 millimeter. This is length. The distance traveled is twice pi multiplied by this distance. It is 35 plus 12 by 2. Do you get my point? Similarly, the lower surface also, area of the bottom, that is also the identical thing. Centroid is here. Now for this outer surface, it is produced by this length 8 millimeter and this distance. Area of the outer surface, it is length of this element multiplied by twice pi multiplied by what is the distance? 35 plus 12. And what about area of inner surface? Length of this?
Sir, 8.
Generating this surface, that is 8 multiplied by the distance traveled for one complete revolution, twice pi multiplied by
35.
35. So done. Now what about the total area? This 12 multiplied by this plus 12 multiplied by this plus outer area plus inner area. If you complete this calculation, you will find one very simple but interesting thing. But you must finish the calculation and check it, that for this element, if this is the centroid, what about the distance of the centroid? 35 plus
41 millimeter.
By 2.
12 by 2. Then what about this total area? Length 12 plus 12 plus 8 plus 8. Okay. Multiplied by twice pi 35 plus 12 by 2. So please, you can check and validate for individual components and for the overall thing. Okay, that is from first theorem. Now regarding second theorem, the total volume generated for this ring-like object. Now please take a screenshot and I will erase these writings. Done.
Yes, sir.
Yes, sir.
Now next thing regarding the volume, it will be area of the plane figure which is generating the solid during its rotation about z axis, that area multiplied by the distance traveled by its centroid, either for a complete revolution twice pi multiplied by something or some angle in radian if it is given by alpha, then that alpha multiplied by that distance of the centroid from the axis of rotation. Now here in this case volume is area is 12 multiplied by 8 and distance traveled it is twice pi multiplied by 35 plus 12 divided by 2, which is the distance of the centroid from the axis of revolution. And you can find out this volume. Okay. Now with this very basic preliminary primary simple discussion, we move back to some earlier portions, that is the circular arc and circular sector. Okay. Now for those circular arcs and circular sectors, we must remember those calculations. Now, in this case, if we have, instead of this circular arc of a central angle alpha, we consider a central angle this much. Now, what about the value of this angle?
Sir, pi.
It's pi. Now, what about
Pi.
What about the length of this arc?
Sir, pi r.
यार
What about the location of its centroid from this axis?
Sir, 2r by pi.
पाई
Now, when we rotate this semicircular arc about this y-axis for one complete revolution, then the area generated will be the length pi r
Area of the sphere.
that multiplied by twice pi multiplied by 2r divided by pi. Now, what about the simplification?
Sir, 4 pi r square.
4 pi square.
So that is that well-known
4 pi.
expression from your school days, that is surface area of a sphere. It is 4 pi r square. At that time, we did not know this proof, but now we know how this thing it is there, and it has not fallen from the sky, just instructed by our teachers. Okay, beta, कुछ नहीं समझना है, याद रखो. Area is equal to 4 pi r square. That is surface area of a sphere. Similarly, if we rotate a semicircular sector about y-axis, what about its centroid?
4r by 3 pi
Along the line of symmetry, that is x-axis. So this is
4r by 3
4r divided by 3 pi, if it is the centroid. Now what about the area?
pi by 2r square.
Pi r square by
So what is the volume? While rotating this plane figure about the y-axis,
2 pi
then is
times 4r by 3 pi times
pi r square is the area generating this solid multiplied by, for one complete revolution, the twice pi multiplied by 4r divided by 3 pi, and simplification will give us
4 by 3 pi r cube.
So this is volume of a sphere. So these two are very basic and very primary application of those two theorems of Pappus or Pappus and Gouldiness. That is, area generated by rotating a plane curve of length L about a non-intersecting axis in its plane is equal to the product of the length of the curve L with the distance traveled by the centroid while rotating the plane curve about some non-intersecting axis, and similarly the volume generated. So these things are like this, and application are quite nice. Now, if we think about this particular problem, this is the 3/4 A is the XC. So come to this diagram. Okay. Now what about the area? Just hold it.
AB by 3.
So for this parabolic sector, if we rotate this or revolve this parabolic sector about this y-axis, then what about the volume generated? It will be area which is generating this volume, that multiplied by twice pi xc. What about this value?
A square b pi by 2.
A square b pi by 2.
So how can you write area AB by 3?
How can I write? बेटा प्रैक्टिस करो, समझ जाओगे. इंटीग्रल डीए, एरिया ऑफ दिस पैराबोलिक सेक्टर, द डिनोमिनेटर, integration 0 to a, this one. So this way I can write. You also can write. Okay. Now please verify other people whether whatever your friend is telling it is correct or not. Three gets cancelled. 2 with this 2. Then pi will be there. A square and b. And here is some nice expression, that is pi square multiplied by b by 2. So area of the base circle multiplied by half of the height, or simply you can write half of pi a square b. Now what about this pi a square b? Pi a square b is the volume of the cylinder.
Yes, sir.
Where the radius is a and height or length of the cylinder is b. Do you get my point?
Yes, sir.
Now I will come back to this part later, but before that we will discuss some simple cases. Here is one axis, suppose it is x axis, y axis, and about this axis, one straight line is being rotated through complete revolution. Then what about the surface generated?
Cylinder, sir.
Cylinder surface
It
area.
will be a cylindrical surface. So if this is the length and if it is at a distance r, naturally its centroid is also at a distance r because this line is parallel to this axis. Then what about this area of the surface of the cylinder? It is length of the plane curve. It is in the form of a straight line here, that multiplied by twice pi r. So twice pi r is the circumference of this base of the cylinder, that multiplied by height of the cylinder. So that is a very well-known expression, twice pi rl, the cylindrical surface area. Now if it is a plane rectangle, in that case, what about the location of the centroid? It is here.
R by 2.
And what about XC? It is half R. This was area, earlier one. In this case, the second case, volume, that is area of this generating plane figure, that is L multiplied by R, distance traveled twice pi multiplied by half R for one complete revolution. Simplify it. So base area multiplied by height of the cylinder, that is the volume. That is also a common formula, what you remembered in your school days. But these things are derived in this form. Now, if it is a cone, for a cone, how to find out the volume and surface area of the curved surface? In that case, if it is the axis about which it is being rotated, and if we have this straight line of length L, then what about the centroid? It is here. Now, if base is of distance R, then what about the distance of this centroid? It is
R by
R. So what about the surface area? The curved surface area for this cone? L multiplied by twice pi R by 2. That is pi R L. Was it there in your school geometry? The slant length?
Yes, sir. Yes, sir. Slant height.
Multiplied by pi R. Now, if this length is not given, it is given in the form of some base angle, suppose theta. In that case, you have to find, or in the form
R
of
by cos theta.
or angle is not given, it is given in the form of the height of the cone and the base radius of the cone. Then square root of R square plus H square will be the length L. So as usual, replace it in that form, length of the generating figure, that multiplied by distance traveled by the centroid of that generating figure or the generating plane curve. Next thing, if we want to find out the volume, now to get the volume, we need to consider a right angle triangle. This plane figure generates the volume. If it is for one complete revolution, then it will be twice pi multiplied by this distance. If it is centroid, XC is how much?
Sir, R by 3.
1/3 of the height of this triangle along this horizontal direction. Okay. Next thing, what about the volume? The area or the plane figure which is generating the solid, area of that is half R multiplied by H, that multiplied by twice pi with distance of the centroid, that is 1/3 R. Then it is 1/3 pi R square H. So just cancelling out this 2 and 2. But one thing, what I am doing on this screen, you should not do in your examination. Okay, so once you write this, etc., etc., and cut it, strike it out, then naturally your examiner will understand that it was not there by mistake, as it is through pen. So naturally there is no question of erasing it out. Only thing, there is a possibility of striking out. So examiner may think that it is your mistake. Okay, so that you should not do. Whatever we do for our mental calculation or some rough calculation, that simply striking out this 2 from numerator, 2 from denominator, etc. Don't do it. Write the full expressions and then you simplify it. So
Sir,
that,
Sir,
yes,
one.
we have
Sir,
an exam from 11 a.m. sir.
okay. Within 5 minutes I will leave you. Okay. Now,
Okay,
Sir,
sir.
sir,
this
in the previous,
1/3 pi r square h, it is that well-known formula from your school. The volume of a cone. So that cone, its curved surface area, cone, its volume, etc. Now, if we consider the frustum of a cone, the lower part, then what happens? Okay, only this portion, the upper one. Sorry, this lower one, this part. There are two ways. One thing, the direct application of that formula, that is about this axis, we need to find out the area of this generating plane figure and its centroid, or calculate the full area of this cone minus the full area or volume for this part, and subtract the upper portion, the portion which has been removed, and either in this form where the standard results are there, 1/3 R, 1/3 R1 or R2, whatever this base value is given there. So in that way, if it is some hollow cylinder like thing, that
Hello.
we can generate.
Hello, sir.
Yes.
Sir, we have exam from 11, sir. Biology exam.
Okay, you leave those who are willing to leave right now, that you can leave, but before that I will take the attendance. Okay, so please give me half a minute time.
Everyone need
Okay, so these small things are there. If it is for some,
So can we leave, sir?
yes, of course you can leave, but those who are interested for 1 or 2 more minutes, they can stay there and it will generate. Now, who can tell me what is the object generated?
sir, hollow cylinder side.
Hollow cylinder. So for centroid, it will be somewhere here. So if the radius R1, the inner radius, and this outer radius R2 are given, then what about this XC? Is half of R1 plus R2. So twice pi multiplied by XC. This is the distance traveled by this, either the plane figure or something like that. Then the area is R2 minus R1, that multiplied by this height. So this multiplied by the distance traveled, that is the volume. So it is, we can replace this XC in the form of R2 plus R1 divided by 2. So ultimately we get 2 gets cancelled, and pi h R2 square minus R1 square. Now what about this pi R2 square and pi R1 square? and that difference is area of this annular portion. Okay, so that area of the base pi r2 square minus pi r1 square multiplied by height h. So this simple but very interesting things are there, and it has got so many applications. And just one second. So I told you that I will come back to this part later. That is this one. So area is 1/3 AB. The volume is half of this cylinder. Now it happens when we have a bucket full of water. This is the level of the water, and you spin it. If this level is touching the brim, you spin it. Ultimately, it will take a shape of what? A curved surface?
Paraboloid.
Paraboloid.
Parabola. Do you know the proof that shape of this curve will be a parabola?
Yes, sir. Sir, we did it in the fluid mechanics part of.
Fluid mechanics part.
So that pressure at different location, the velocity, the centrifugal acceleration, etc. With all such equations, we can find it. Now, when it is rotated at a particular speed, it is spilling out of this container, and finally that parabola touches the bottom center and it touches the topmost level. In that case, it is a parabola, and volume of this parabola is half pi r square h. So very simple calculation, but practical example is just take a bucket full of water, put your hand there, spin it. You increase the RPM, and finally you will find water is spilling out, and it takes this position. Now, if it is some intermediate, this is the water level. In that case, it will not spill out. It will take only this gradual depression like thing. It increases, the lower level decreases. Finally, when it touches the bottom, it will be here. Now, what about these heights? With reference to the original level, it is simply 50-50. Okay, so 50% of water moves out of this container, 50% remains. So here also, when you allow it to settle, the spinning speed reduces and it settles, then you will find the free surface is of half of the depth of the container. So these things are very simple, very interesting, but you please do it. Okay, problems will be there in your mid-semester exam on 15th. You don't have much time. Please do practice. Okay, so tab tak ke liye give me permission.
Sir, but you said that trusses and that will only come in CA2 or mid-sem.
This is the part of the centroid, extended centroids.
Okay, sir. Okay, sir. Fine. Sir, this part, can you explain once more that h/2 part in the last which you have written?
Now, what about the volume of water? It is half of the full cylinder. Okay, so what about this empty part? That is also half of the full cylinder volume.
Yes, sir.
So when you allow it to settle, it is not spinning anymore. It is static water. Then it is half H. So what about the volume of this? Pi r square multiplied by half H. So naturally, what about this empty part? This parabolic or paraboloid volume, which was the empty part. So now the empty part is half cylinder like thing. So half portion of that bucket will be full of water and the remaining part will be empty, as it was there in this case.
Okay, sir. Thank you, sir. Yes.
Okay, it was water and it was empty. So please join your exam and please collect some doubts and problems and troubles. We'll discuss in the next class.
Someone please also stop the recording.